Welcome to the Hardscape Huddle, the ultimate podcast for contractors looking to elevate their game in the hardscaping world. I am your host, Kyle Staffa. On this show, we're all about sharing the knowledge and skills you need to excel your craft and build your business. From mastering the latest installation techniques and staying ahead of industry curves, the Hardscape Huddle is your trusted resource for all things hardscape construction. Whether you're a seasoned veteran or just getting started, we've got the tools and tips to help you build the business and exceed your clients' expectations. Join us each week as we sit down with industry experts, share insider secrets, and deep dive into the nitty-gritty of hardscape design and installation. Get ready to level up your skills and take your contracting business to new heights. Welcome back to another episode of Hardscape Huddle. I'm Kyle Staffa, your host today. And today we are welcomed by Ryan from Techo-Bloc and Paver Pete.
Hello, hello.
I see Techo-Bloc still has the same wardrobe designer. Still got the same shirts on, boys. So you're looking good.
These are our hardscaper.
Yeah, what is hardscaper?
Hardscaper is a secondary area in the Techo-Bloc. It's educational department of the for hardscaper.com, where we have educational videos and teaching. It's part of our showcase that we do, powered by Techo-Bloc, Hardscaper. And it's just...
So contractors can take new hires,
Yep,
or someone who just needs a refresher, and in English or Spanish or French, they can go watch a video on a component of interlock and pavement, segmental retaining walls, or whatever. Take a quiz. If they pass the quiz, they can take the next video and next quiz. And there's lighting. There's bidding, there's marketing, there's selling. There's a bunch of different components, modules that they can get. It's free. So, and it's not a sales pitch for Techo. That's why we use the word hardscaper. And you can go there and,
if they want to be a Techo Pro for this, or anybody can log in and do it.
Anyone and log in.
That's awesome.
And the cool thing about it is if I'm new to the industry, I have to put in my coach's name, and my coach gets notified that I logged in. And that I passed 3 sections, and that I finished that section and I moved on to another section. So it's a great way for the coach to see that somebody that they hired is really doing what they promised they would do, which is go on and get, more information on the products.
Right. So it's elevating the business organically, basically. On hardscaper.com, you teach about, you said lighting, possibly drainage.
Yeah.
Retaining walls, pavers.
Yeah, permeable pavement's coming. Right?
Okay.
Yeah, we're working on it right now.
Retaining walls?
Yes.
Yeah.
Okay. Retaining walls here at the Jersey Shore. Thank goodness it's a pretty flat area. We do most everything where it's sitting walls and things like that.
Feature walls.
Feature walls.
Not structural components of the landscape.
Correct.
Okay.
So let's talk about retaining walls briefly. Let's talk about some base products. Old-fashioned way was 3/4 clean or 57s, both the same product, just different names. Compacted, and we're laying right on top of that. We didn't have, this was going back 30 plus years now, we didn't have special tools and things like that back then to screed out the bases. Which we do now. Yeah. It makes it a little bit easier.
And
Nunchucks.
Yeah, exactly. And we sell a lot of them, believe it or not.
They work great.
Yeah.
Counterintuitive screeding, not with the trench, but against
it. Right.
But it works.
And once you have that screeded out, the block lay easy.
Yeah. Yeah. One of the neat things at Techo is that all but 2 of our retaining walls are double-sided structural all-in-one. So you can use them in feature wall construction or structural wall construction. And you can had a conversation with a contractor in Maryland yesterday on a SEMA wall. I know you guys do a lot of SEMA wall, and he wants to build a setback wall, battered. It's going to be geogrid reinforced, and then he needs a small section double-sided in a vertical application on top. I'm like, it's the same block.
Yeah.
It's literally the same. You're just changing the independent mechanical device, which at Techo is free, comes packaged with the block. You're just changing the setting on them. They're all, all but 2 are double-sided structural all in one. But in a feature wall, sitting walls, fire pits, grill islands, elevated water features, planting features. Planting features are hugely popular right now. No one wants to bend down to take care of their vegetable and annual and perennial gardens. So having them, 18 inches off the ground makes it nice to sit on and
sure.
weed and maintain your your herbs or whatever it is that you're doing. But
So this wall in Maryland, just to get back on that a second, he or she is gonna put this put GeoGrid in it.
yeah,
How high is this wall?
it was 8 feet at its tallest section on the main course of wall, and then 6 feet down to 0 on the second portion.
So he's gonna put the GeoGrid in every 20 inches, give or take.
There's some industry standards. My recommendation is to get a new copy from your local Techo-Bloc distributor of the Techo Spec Guide. It's probably the best guide for our products, but even installation in general in North America, maybe the world. It really is evolved in our 35 years to just a huge resource, the encyclopedia of hardscaping, for lack of a better term. But if you're using the raffinados in front of us, it's our refined wall system, smooth textured, pronounced joint, real modern colors,
Yep.
Light grays,
And
beiges.
what color is this?
Probably pronounce it wrong. Crema.
Yeah,
Cafe crema, not coffee crema. So, but it's a beautiful new color. It has some lighter browns to it and a nice light cream to it as well.
Yeah, kind of that in between the chocolate browns and
Yeah.
chestnut browns and the beige cream. So kind of that in between.
Right in the middle. And is
Yeah.
this the only size it's available in?
No, you can get it in the 180 size as well, and you can get it in a cap. The new raft.
So this is 3.5.
It's 3.5.
All
90.
3.5 inches.
Yep.
Also comes in 7-inch,
Mhm.
right?
Okay.
Yes.
So you can do them either on their own or together. You can mix them together.
So now on this block here, I see we have grooves in it. So how am I going to finish the corners?
So we do have corner/pillar block as well.
Okay.
that comes
So you
with
can
it,
make
it works
pillars, light
together.
pillars, and
Mhm.
things like that.
Yeah, or dye it into the gray. Now, obviously, the block would be laid down, right?
Correct.
This represents the top of the block. This is the face, that kind of clean, modern,
Yep.
smooth
chamfered
textured
edge.
face, and it's hollow core, so you have void fill interlock.
Mhm.
The aggregate feeding through. You have the independent mechanical device, and because of the density, this block is 5,000 to 6,000 psi, which is almost double the industry standard compressed strength. You have a tremendous amount of shear strength, block to block contact. So if you have the right pattern, you don't want all the seams lining up. You have the right shear strength, void fill, and independent mechanical device, which this does. You have all 4 types of interlock.
So if
in
I'm
this
doing a
application.
true structural retaining wall,
Yeah,
okay, you're talking about block to block contact,
yeah,
right?
yeah.
Let's say I don't want to do that. I want to glue it.
You're taking a product from supposed to be segmented to be able to be flexible system. You're making it a rigid
Freeze
system,
off, frost.
Yeah.
and you don't want that. It's supposed to be flexible system, so you're gluing it. You're making a rigid system, and that's where you're gonna have failures potential or water issues.
Yeah, hydrostatic pressure.
So use the pins.
Use the pins. They're free. They're packaged with the block.
It's
You can
free,
never forget
it's
'em.
Quicker. It's cleaner.
Yeah.
Mhm.
Why
It's
would I not?
stronger.
Yes. Why would
Yeah.
I not?
Glue between the blocks changes the shear dynamic. So the shear strength between units is now lubricated by this adhesive. So now it's easier to slide or pull the grid out or whatever, however you define it, shear strength or grid pull out with the glue than not with the glue. So it's there's a few manufacturers out there that don't do a good job with height tolerances that tell you to glue them together because that's a great way to fix the height tolerances.
Just shim it with a penny.
And, piece
Shingles.
of rope or asphalt shingle.
Yeah.
Yeah. And we're not perfect. We don't claim to be perfect. That's not our intention, but we're as close as humanly possible on our dimensional tolerances on our heights of our block. We use precision machine height gauges. We use lasers on every layer. If the layer is made wrong outside of our tolerance, it automatically gets thrown away. If 3 layers get made wrong in a row, the whole machine shuts off, which is a catastrophe. Yeah. And you got 2,000 pounds of wet concrete about 60 feet in the air.
Yeah.
It's a big deal to shut it off, but we're very serious. So you don't need to do that. Minor imperfections in the block are part of the design, part of the equation that an engineer would use to determine the strength of the retaining wall. So, but if there were minor imperfections, there are little pieces of grid that can be used to shim something up or something like that. That's very easy to do. But glue is not an option.
Got
Yeah,
it.
the
Not
pin
an option.
system's part of the interlock. It's the mechanical part.
Yeah, independent mechanical device. Yeah.
So let's go back to that wall in Maryland. 8 foot tall down to 6 foot.
In one section, yeah.
Yeah.
6 foot to 0 on the other.
Plan on getting water away from it?
Yeah. I think that's probably number one rule. If you look up the Concrete Masonry Hardscape Association we talked about in our last podcast, the governing body for retaining walls and paving stones, they have a 3rd edition guide to wall construction. I think page 1, paragraph 1 is never run water towards a retaining wall. You need a good column of clean stone that allows water to get to a drain tile and then out to the environment some way, positive gravity flow or through the face of the wall, something like that. And you need a swale at the top and a pitch at the toe, again, to keep water from getting in there. So the only thing that water-wise, hydrostatic-wise, which leads to additional lateral load pressure, the weight of soil, the only concern we have is water traveling through the ground. So water that may infiltrate at grade, get in behind our wall, and then travel laterally towards our wall, or just natural groundwater that we need to handle.
Can we fix that with a piece of pipe?
Yes.
And no.
and no. There's some drawings from the industry that show a chimney drain, either a column of aggregate or a composite, some type of dimple drain board or something, that extends up your excavation, that catches that groundwater. And there's an equation. If the groundwater is half of the height, then it's 0.7. If it's 0.7 or more, it's the entire height of the wall. That you would have a chimney drain catching water traveling through that excavated soil, that area that's been excavated, that soil, and then running that down to so that chimney drain traveling water to a blanket drain, then to the drain tile and out to the environment. And there can be other drain pipes throughout that horizon. I have a drawing.
Sure.
I'll put it up on the screen, that shows, my preference, which would be for a larger column of clean stone, period. So we have an excavation. I'm going to be up here on the screen here in a second.
Okay, perfect.
A larger column, I say 3 foot or more. Industry says 12 inches, not 12 foot, but 12 inches minimum column of clean stone. I think that's incorrect. I think they should be saying 3 foot recommended or more. So here we see a 3 foot column of clean stone
from the back of the wall.
Yeah, 3 foot deep. So you see you have a 4 foot grid length, blocks, in this example, let's just say 12 inches to make the math easy. This is a 10-inch block.
And that's what I was going to say. You have to excavate out that far anyway because of your grid.
That's right. Yeah, you need the space. And I'm a proponent of the fact that 3/4 inch clean stone that meets the right ASTM spec or AASHTO spec. So it's not 1/4 inch stone. It's not 1.5 inch stone. It's true 1/2 inch and 3/4 inch blend of stone. Less than 5% passing the 200 sieve, 90% fractured face, all those different technical things. That if that entire column is clean stone, any water that may be traveling through here is going to osmotically run down to our pipe and out to the environment,
right?
Which is my preference. So I don't have to worry about compaction. I don't have to worry about the grid being installed correctly. I don't have to worry about nuclear density tests, making sure that I'm at 95% standard Proctor density on that soil compacted within 3 foot of the back of the wall. Out here, I'm not worried about it. I can bring in a big double drum roller. I can bring in a roller. I can bring in a big CR6 Compatrol diesel compactor. I can knock it and not worry about pushing my wall. But that 3 foot, very difficult without pushing the wall. You can start the wall's failure during the compaction of the backfill.
And then you never can go backwards.
Oh, wow. Yeah.
What else am I looking at there? I see 3/4 clean. It looks like I have a small swale up top.
Yeah. We talked about that. This is that low permeability clay fill. You could use an EPDM liner, concrete, asphalt.
Slowing the infiltration from top down.
Almost eliminating it. Yeah. An EPDM liner, for example, or some anaerobic clays are impermeable. You can make a pot out of them. It holds water, and they're very low rate of infiltration to none. Concrete, asphalt, those kinds of mediums, and creating a swale with positive pitch of water somewhere. And I may have a drain every 25 or 50 feet behind the wall so that water runs through that swale, gets caught in the drain, it runs down somewhere, wherever I want it to go. Or if it's a shorter wall, then I can run, just run the water off into the environment. But,
Gotcha.
This is a big deal. Then you have your topsoil, which you need a good layer of topsoil so you can put erosion resistant vegetation in on top of it. Not trees, but shrubs and ornamental grasses or something that can
Smaller
handle
root systems, but they're going to absorb that water.
Absolutely. It's God's grid, right?
Yeah.
Roots is God's grid, right? It stabilizes the soil. So, and I'll be honest with you, a lot of really good contractors, really good hardscape and retaining wall contractors, if this isn't properly explained, can lose the job because a lot of people just run the grade right to the cap, hoping that water either sheets over the cap into the base. Terrible idea. Efflorescence, mineral deposits, sediment stains.
How about
Terrible.
just erosion on the bottom block?
Or erosion on the bottom block, which accentuates the amount of water there. Or there's some settlement and the water runs directly behind the wall, carrying all those things that I mentioned, sediment and organics and all kinds of stains. So this is always worth, we talked in our last meeting about educating on social media, just highlighting a digestible bite of information. You call it content, but a digestible bite of information. If you're buying a structural retaining wall and they're not talking to you about low permeability clay fill, EPDM liner, concrete, asphalt, paving stones, creating a swale, a layer of topsoil and erosion resistant vegetation, part of the erosion and sediment control measures at the top of the wall, don't hire that contractor,
Right.
Mr. and Mrs. Smith, right. Yeah. Don't hire them. You need good one.
If I was a contractor getting back into the contractor business or what have you, I would not be afraid to show my homeowner this. This is what I'm doing. This is why I'm $50,000, $80,000, $100,000. This is why he's $25,000.
Yeah.
And, part of this podcast is not only to elevate the hardscape industry, but it's also to, let the homeowners know, the ultimate end user, this is what to expect. This is how it should get done.
Right.
Don't be afraid to vet your contractors.
Yeah.
And contractors need to vet the homeowners too.
Yeah. You hear contractors, and I'm a huge fan. I was one. Some of my best friends are contractors, many of them actually. I've been around 30 plus years, so I have a lot of really good friends. And they'll say, well, so-and-so's messing up the market and so-and-so doesn't do it right. And they're really, telling people the wrong things. And I'm like, well, this isn't the old days. You have a platform, Meta, LinkedIn, X, to tell people these things.
Right.
You have a website that people could search. We have great videos, I know you do too, on retaining walls that contractors can put on their website with meta tags that make sure that it's properly labeled, that explain the GeoGrid doesn't hold the wall back, but that it stabilizes that column of aggregate behind the wall. And if we're doing a good job on our job sites of shooting little videos and using Techo and Staffa's data that we have and putting that up on social media and on our web, well, we can help hurry that individual out of the retaining wall part of the industry,
right,
and doing something else, and having people understand that spending the appropriate amount of money to get a wall that has an 85 to 110 year design life that will last longer than they will, and their house might, right? That's what really we want. This is Great Wall of China stuff. This isn't new.
Right. And you see these big retaining walls in some of these new, condominium complexes and stuff. They're holding back the parking lots. Yeah. If it's done correctly, it's never going anywhere.
Oh, yeah. Holding back restaurants, buildings, banks.
Yeah.
Absolutely.
So I see that piece of pipe at the bottom there. And
the drain tile.
Yes. Yeah. And going back to your big project in Maryland, that wall is, I don't know, let's make up a length, 200 feet long.
Mm-hmm.
I can't just put coupler to coupler and connect that pipe to daylight on the outside of the wall. How do I drain it through the front of the wall?
Okay, well, you couldn't. Not in this drawing. So this drawing is for a wall that's under 50 feet long.
Okay.
Which is honestly the most common walls that we sell and that you sell. And, they're just more common than these long 150 or 200 foot long walls. So in that application, typically, the pipe would be as low in the horizon as possible, 4 inches above subgrade. You always want 4 inches of good clean stone all the way around it. Our base thickness is typically 6 inches thick, 6 inches beyond the heel, 6 inches beyond the toe, 6 inches thick with 6 inches embedment. So the 4-6 rule, 6, 6, 6, 6. So that pipe would be perfect so that we can daylight that pipe at the end of our wall and just run it to, I don't know, some area that we built a little dry riverbed or something like that. There's probably very little water coming from behind it. But if it were, we don't want it to cause erosion where it exits. So this would be a very efficient, productive, less expensive way to build a retaining wall. But if I had to build a wall that was, well, let me back up just 1 second. This wall is going to drain here. It's going to drain to a dry well or a subterranean drainage structure or somewhere, the stormwater system, if it's longer than 50 feet.
Right? So in this picture, you're capturing that wall maybe to do lawn irrigation.
Yeah, I could harvest water out of that if I wanted to. It's basically a modular cistern, that bolts together. Now, if I'm building a wall where I can't do that, I can't tie into the stormwater system. I can't tie into a dry well, a cistern, any type of subterranean drainage structure. Then I have to elevate my pipe. Now, this is a different wall. This requires dense grade stone, so 3/4 inch angular stone down to fines. At the right range, what we call ASTM 2930 material.
So we call it a road blend or QP, DGA. Yep.
As long as it meets the 2930 spec, I'm fine.
Yep.
But you shape, hardness, and gradation of that aggregate. Now, getting that base compacted in that 6666 kind of model that we talked about to 95% standard Proctor density over properly compacted soil subgrade and geotextile and all the things still true. Not so bad in the trench, right? I mean, I can get my big compactor in there and get my CR6 reversible comp patrol sensor. Oh, yeah. I can, and I have a reading. It tells me, but to get my pipe high enough with that 4-inch column of clean stone all the way around the pipe, now I have to use that same dense graded stone, 2940 material, and again, get it compacted to 95% standard Proctor density without moving the wall. That's tough.
So how are you going to do it?
Patiently.
Carefully.
Probably with some way of measuring the density, like a dynamic cone penetrometer, because I can't run a CR6 behind that wall. It'll push the wall for sure. I mean, right behind the wall. I might have built that wall correctly with a batter or vertical or whatever. And Techo-Bloc's walls can go true vertical, 0-degree batter, or whatever batter we give you in the spec book, quarter, half, 3/4 inch setback, whatever the setback, 3/8 setback that we want. Once I've got that set, and I've took all the time, I put a big diesel, I'm moving it. I'm moving it to a negative batter, and that begins the failure.
Before you're even finished.
Yeah, it is a tougher installation. You were talking about flowable fill.
Yes.
On a project, which is a self-leveling concrete.
Right.
So a lot of people will use dense grade as their base or flowable fill as their base, which is the same bearing ability, and then go back here behind the wall with flowable fill self-leveling concrete. And that gives them the ability to wait just a few hours for it to cure, not all day or a couple days, and then clean stone in our pipe. Now that pipe's going to daylight here. I can build forever long.
Yeah. What about, what walls would require different grid lengths? Obviously, height of walls, correct?
Yeah.
And what they're holding up, I would assume.
Yeah, I think, there's two types, cut and fill. So if you're building a retaining wall and then filling in an area, well, you're using select fill. So you're going to dissipate the need for geogrid, maybe even eliminate it, right? Because you're bringing in good clean stone or a good sandy soil or something like that. If it's a cut job where you're cutting into the soil, well, part of that is understanding that you have to excavate to the angle of repose. You have to excavate at a stable angle. I know you have a lot of sandy soil by the shore.
Yep.
But if you're in a clay soil, I mean, that can be a pretty steep angle. 15, 20, 25 degrees is pretty steep.
When you're excavating and estimating, right, we got to figure out the cost of all of this stone, all this aggregate that we're going to put back in.
Right.
And
because often we're exporting what we excavated.
And we got to pay to get rid of it usually.
Yeah.
So we need to put that into the bids.
Yeah. I could use it, not within 3 foot of the back of the wall, but it's going to be slower to compact. So I have to do a cost benefit analysis. If I'm going to use the in situ soil, which has a high fine content, a high clay content, let's say a CBR of above 5, but anything below 5, I'd be real nervous about using it. You could, would be real nervous about using it. I could get it compacted to 95, but it's going to take time.
Yeah.
So I have to balance out hauling, an independent hauler taking it away, dumping it. Maybe that's their problem, hopefully, where they're going to dump it, and then bringing in clean stone. But, there are times in water applications, we've done a number here in New Jersey. You've done a couple with our skyscraper, our big block system,
1,000 pound
1,200 pound block, where the entire area that's been excavated is filled back in with clean stone. So you have very little lateral load pressure, very little hydrostatic pressure, and you've dissipated some of your need for grid with the weight of the block. So, but typically excavated properly, soil conditions, surcharge load. You notice there's a slope at the top. Yeah. There's weight there. There could be a live or a dead load. I'll give you an example of something that's both. A live load would be snow melting, starts to move. You got a big pile of snow that's been plowed up at the top of the wall. Back to your parking lot example, starts shifting, starts moving. The Wawa cups start moving. Yeah. All that kind of stuff starts happening. So that's live. But while it's still cold outside, that is a dead load. It has weight. It's not moving. It's not shifting. It's still frozen outside. But there's now additional weight, surcharge, additional weight at the top of the wall. So that's going to increase our need for soil reinforcement. So the keys are grid placement. Where does it go? Depth. How deep does it go? And the type we're going to use. And we want to always let the engineers give us, or our design team, we have a design team at Techo to help you with preliminary design for your wall, and we'll give you the math on what is the best value for the client in terms of grid placement, depth, and type.
So what I just heard you say, use the pin system because it's free. It comes with the block.
Yes.
Independent mechanical device. Yeah.
It's stronger.
Yep.
Okay. Grid, cheap insurance.
Yeah. It's
It's
not an option.
Yeah.
You have to follow the manufacturer's recommendation on grid placement, depth, and type.
Always go back to your distributor, the manufacturer, for specs.
Yeah.
If you're uncertain on how to build it,
you can find those in the spec book.
Yeah.
It has a wall
it's
design
probably
chart.
online too, right?
Online, definitely.
Okay.
Grid placement charts. Yep.
We got to always consider the drainage above and behind the wall.
Above, at the toe, and behind the wall. All three.
So 3 locations.
Yes, absolutely.
What else am I missing?
Well, we talked about not gluing them together.
Correct.
Right? Because we have a system that
only glue the cap.
Only gluing the cap, and that's just, kids playing and running and that kind of stuff. And it has nothing to do with the structural integrity. It's, again, kids.
Now, when I glue my cap, just glob it on, or is there a way to do it?
With the flow of water. So basically you don't want to run the bead across. You want to run it in strips.
Okay.
Stripes.
From front to back. In this case here, we're going front to back.
Front to back.
Yeah.
Okay.
But you don't want to connect them. You want to be able to allow airflow and any water to get out that it can get out. Because once you block the water, that's where you can get more hydrostatic and water issues.
Yeah, lateral load pressure. Sure.
Yeah.
Yeah, and we mentioned it in the last podcast, and we talked about tools and how to price your tools and all that kind of stuff. But a HEPA particle vacuum, making sure, you're core filling this. You're filling this with clean stone. When you put another block, let's assume it's a structural wall, when you put block to block, there's going to be a taper between the 2 units. That has to be full of clean stone and 3 foot of clean stone behind it. You put all those things together, the top of this block is now covered with
debris.
pebbles and rocks and a little bit of fines and stone dust and a mix of stuff. If you don't clean it thoroughly, I'm not talking about the back of your hand, a horsehair broom, a brush that you use to clean your tires, a HEPA particle vacuum to keep those airborne respiratory silica particles out of our lungs, because they have an aerodynamic diameter.
right.
They will stay buoyant in the air. Keep them out of the air, vacuum it off, and then you're going to get greater shear strength block-to-block contact, and you'll have less efflorescence, mineral deposits, organic stains, silt stains, all those kinds of things.
So again, guys, thank you so much for coming today and joining us here at the Hardscape Huddle, where we look to collaborate with manufacturers like yourselves, distributors like myself, and just partner together, get the industry standards all to one, and solve everybody's solutions. So again, thank you for tuning into the Hardscape Huddle. I'm Kyle Staffa. Have a great day.